Dear participants, I welcome all of you in this lecture of inferential statistics. As I already told you, we can categorize statistics into two different branches. One is descriptive statistics that we have already seen in last lecture, and then in today's class we will discuss inferential statistics. So, in last class we have seen how to measure centrality like mean, median, mode, and then we have already seen how to measure spread. I mean how our data is scattered, right? So, for that purpose we are having range and then standard deviation. So, we have already seen these two topics in last class, and we have already solved certain problems related to centrality and spread. In today's lecture, we'll discuss idea behind inferential statistics and I mean what is the purpose of inferential statistics actually, and why it is very much important as far as data science is concerned. We'll see what is population, what is sample, and then we'll see certain sampling methods as well, and we'll also compare correlation and regression. So, what is the difference between correlation and regression, and what is the similarity between these two? Then we'll move on to introduce you hypothesis testing. So, why do we need inferential statistics? And what is the purpose of inferential statistics actually? Suppose we want to know the average age of data science professionals in India, right? We want to find out the average age of data science professionals in India. So, there could be two possibilities, and which one should we use? The very first one is meet every data science professionals in India, note down their age, and then calculate the total average, right? So, you have to meet every data science professionals. Let's say there are 10,000 professionals across India. So, you have to meet every professional and ask her or his age, and finally find out the average age. The other possibility is to handpick a number of professionals in a city like Bangalore, or you could select Noida as well, note down their ages and use it to calculate the Indian average. So, which approach should we use? In the initial approach, would be highly impractical, right? Due to the vast resources and time it would consume, right? So, you have to select, you have to visit each and every state, and then probably each and every district, and then you have to meet data science professionals. On the other hand, the second approach appears more viable, right? However, it comes with a significant potential drawback. And what is the drawback? If the demographics of Bangalore are not representative of India's overall population, there is a substantial risk of inaccurately determining the average salary of data science professionals across the nation. So, the question remains, which technique could we employ to accurately determine the mean age of data scientists throughout India, right? So, here actually inferential statistics will help us. So, how we will define inferential statistics? Unlike descriptive statistics, which help us describe and understand features of our data that we have already seen, inferential statistics allow us to make predictions or inferences about a larger population from a sample. Inferential statistics allow us to make a prediction based on sample actually. So, how to select sample and what are the different sampling techniques, very soon we will see the different sampling techniques. It is like being a statistical detective, actually, investigating and making educated guess from data you have collected. So the target is to take a sample and find some value, let's say a mean, and and inference about a large population, right? So that is the target of inferential statistics. Since we cannot visit each and every elements in the population, because it is not practical, that we have seen. So that's why we are taking a sample, and then we'll find out certain we are performing certain statistics, and will inference um, um, about a larger population. So what is the importance of inferential statistics? Making conclusion from a sample about the population to conclude if a sample selected is statistically significant to the whole population or not, right? It is very important whether the sample that you have selected it is actually statistically significant or not, as far as the whole population is concerned. Comparing two models to find which one is more statistically significant as compared to other. In feature selection, whether adding or removing a variable, or you could say feature, helps in improving the model or not. So for all these purposes, we can use inferential statistics. So certain key concepts we will discuss as far as inferential statistics is concerned. Population versus sample. So what is population, what is sample? Sampling methods, correlation and regression, and hypothesis testing. So what is population and what is sampling? Every inferential statistic is based on the idea of a population and its sample. And what is population and what is sample? So the population is the whole group you are interested in. Since in last example, I was talking about average of data science professionals. So the population is the each and every data professional across India. So this is the population. While a sample is a smaller group drawn from that population. So a smaller group, let's say I'm taking Bangalore, I'm considering Bangalore and then visiting each and every data professional. So this is my sample. The goal is to use the sample data to make inferences about the population. Let's say one more example. If we want to know the average height of adult women in India, so we cannot measure every individual, since we are having huge population. So we cannot measure every individual in this case. Instead, what we will do, we take a sample of women and use that data to make an inference about the average height in the entire population. So we will take example, and how to select a sample, that we will discuss. So there are different type of sampling methods. One is simple random sampling, stratified sampling, and cluster sampling. A sample and resulting statistic will be useful only if it is a representative of the population. So why we are having different type of sampling, and the target is to select a proper sample in such a way that it is actually representative of the whole population. The very first one is simple random sampling. Simple random sampling is the basic sampling technique where we select a group of subject, or you could say some sample, for study from a larger group that is called a population. Each individual is chosen randomly and entirely by chance. It is very important. each individual selection of selection of individual should be entirely by chance, right? So that we call good sample, such that each individual has the same probability of being chosen at any stage during the sampling process. So the probability of selecting an individual is actually same for each and every individual. Let's say a case, and imagine we are conducting a study on the eating habits of high school students in a city. Let's say city of Bangalore. To obtain a simple random sample, we could assign a number to every high school students in the city's public school directory. So suppose city is maintaining a public school directory. So what we will do? We will give a random number to each and every entry in that directory, right? And then we will select 100 students in our study. Let's say 100 students. Suppose in Bangalore city, 10,000 students are there as far as high school is concerned. Let's say. So what we'll do? We'll collect a public school directory and we'll use a random number generator to first of all we will give individual number to each and every student, and then we'll use a random number generator, right, to select 100 students. Let's say 100 students. Let's suppose 200 students. So this would be a good sample. As far as stratified sampling is concerned, in this method of sampling, it involves dividing the population into smaller groups known as strata that share a similar attribute relevant to the research. So, whatever our research is, let's say our research is, we are collecting adult women for finding the average height. Let's say we are collecting data science professional to find their average salary. So, all should share the common attribute. Samples are then taken from each stratum, each I would say group, to ensure that the sample includes members from each segment of the population, right? So the target is to select individual members from each segment of the population, from each stratum, strata actually. And then in this case, suppose let's say an example. I will discuss it with an example. The example that I discussed in the just previous slide. So continuing with our study on high school students, suppose we want to ensure our sample accurately reflects the city's demographic in terms of socio-economic status. So we can divide the entire student population into different strata. Example, low, medium, high. So we can divide the whole student into different population, right? Low, belonging to low economic zone, high, medium, high. So in this way, we can divide the whole population into different socio-economic group, and then perform simple random sampling. So within each strata, within each group, this ensure that students from all economic backgrounds are proportionally represented. So in the previous case, in the previous random sampling, so we are not considering different groups actually, but in stratified sampling, we are considering different groups, and from these groups, we are again performing the random sampling. So that is the stratified sampling. Now we will discuss the cluster sampling. Cluster sampling is a technique used when natural groupings are evident in a statistical population. So, natural grouping, suppose you are having several citizens, right? So, the natural grouping could be, we can divide into these individuals into different states, right? And similarly, they could belong to different districts. So, district wise, we can make a different group, or state wise, we can make a different groups. So, this is the natural grouping. It involves dividing the population into clusters. First, we divide the population into clusters, and then one or more clusters are chosen at random. And everyone within the selected cluster is sampled, right? So, the clusters may be, for example, individual villages or geographical areas, so individual state and so on. So, continuing with the previous example, if we wanted to expand our study on eating habits to the national level, right? It may be impractical to use simple random or stratified sampling due to the large and widespread population. So, the population is actually the population of whole India. Instead, we could use cluster sampling by dividing the country into clusters based on district or state. So, we can divide the whole nation into different states and different districts as well. We then randomly select a few districts and survey every individual. This method can save time and resources while still providing a representative sample actually. So, in this way we can perform the clustered sampling. So, we have seen three different categories of sampling. So, the very first was simple random sampling, then stratified sampling, and then we have seen cluster sampling, right? And what could be the examples and applications? So, in medical research, suppose researchers use researcher want to use inferential statistics to determine the effectiveness of a new drug, right? Suppose a new drug has been discovered by pharmaceutical company, and they want to test their effectiveness. So, again, which type of sampling should we take, right? So, we cannot perform test on each and every individuals of a particular nation. So, again we will select certain sample, and then we will try to take inference from this sample for the whole population. Economists use inferential statistics to predict future economic conditions. Again, they will take certain sample and they will try to inference. They will try to take inference for the whole nation to predict future economic conditions. Businesses use it to understand consumer behavior and to improve products and services, right? So, let us say Amazon is maintaining, there are several customers in Amazon and Flipkart, right? And they can, understand, to understand the consumer behavior, they can take certain samples, right? So, they can take samples of users from Delhi, users from Bangalore, users from different cities, and they will try to find out their feedbacks and their preferences, and finally they can improve their products and services. Since like Amazon is providing several services, so they can improve in this way. So, that is very useful as far as these type of decisions are concerned. Now, we will see what is correlation and regression. So, inferential statistics also encompasses correlation and regression analysis, which allow us to examine the relationship between variables. For instance, we can use regression to predict weight loss based on calorie intake and exercise frequency. So we can predict weight loss. So again, this is a regression analysis type of problem, right? Regression type of problem. Correlation and regression are about the relationship between variables. While correlation measures the strength and direction of a relationship between two variables, direction, it means either it is positive direction or negative direction. It means if one variable uh, value of one variable of feature is increasing, so if other parameters value is also increasing, it means it is a positive direction. Negative direction, it means if one variable value is value of one feature is increasing, but the value of other feature is decreasing. So this is the negative direction. So using the correlation, we can identify this type of relationship between features. And regression allows us to predict one variable based on the value of another. So suppose you want to predict lung disease based on certain individual parameters, right? Independent parameters. Let's say age, weight of person, and blood pressure level, and several other parameters. So on the basis of these parameters, they want to predict the lung disease. So that is actually that can be performed using the classification and regression, right? So that is the relationship between correlation and regression. Then there are certain techniques to validate inferences. How will you validate the inference? To determine whether the inferences made on a sample are valid, statisticians use a variety of techniques. Here is a detailed explanation. So what technique they will use? So hypothesis testing, they can perform hypothesis testing. Again, they can also perform validation techniques in data science, right? So hypothesis testing is one of the main tool of inferential statistics. It allows us to decide whether there is enough evidence to support a particular belief or hypothesis about a population. Suppose if a new drug came into market, and if we want to know whether this drug is more effective than the previous drug, right? So this type of assumption, suppose someone says this drug is more effective than the previous one. So this is a hypothesis actually. This is the belief that need to be validated. So the validity of inferences is often tested by setting up a null hypothesis, that is there is no effect or no difference. So that is called null hypothesis. And an alternative hypothesis, that is there is an effect or a difference, right? So alternative hypothesis says there is a difference actually. So there is a the newly discovered drug is more effective than the previous one. So that is called alternative hypothesis. Null hypothesis actually says there is no such. The newly discovered drug is not effective than the previous one. And if there is a certain change in the result, this is whole because of chance, not because of effectiveness of the drug. So that is the null hypothesis. We'll see null hypothesis in a separate lecture. And the another one is cross-validation technique, such as k-fold cross-validation or simple training and testing data. So we want to, in case of data science, the whole data set is divided into two different sub data set. One is called training data set and the other one is called testing data set. So we want to train the model on the basis of training data set and we'll validate it using the testing data set. So that is one more type of validation. The other validation could be a k-fold cross validation, which is more effective. In this k-fold cross validation, the very first step is to partition the data. So split your data. In this case, in partition of data, you need to split your data set into k equal size segments of folds. Then the next step is train and test. So in this case, you will use k minus 1 folds for training your model and the remaining fold for testing, rotating the test fold each time. What does it mean? Suppose you are using 3 fold cross validation. So what you will do? You will use 2 folds for training your model, and the remaining model, it means since you are using 3 fold cross validation, so you will use at a time, you will use 2 folds for training and 1 fold for testing, and then in this way we will rotate it. So first and second will be used for training, third one will be used for testing, then second and third will be used for training and the first one will be used for testing. Similarly, first and third will be used for training and the second one will be used for testing. So in this way we will rotate it, and finally after testing with each fold, average the result to get an overall performance metric. So this is the way how k-fold actually works. Now to summarize it, what we have seen in this lecture, we have seen sampling methods. So we have, under sampling method, we have seen simple random sampling, then stratified sampling and cluster sampling. What is the difference between correlation and regression, that we have seen, and how to validate inferences, the techniques which are actually that can be used to validate inferences. So all these we have discussed in this class. Thank you so much for joining the class. We will meet again in next lecture.